Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Tabo Mboweni. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pakama Research and Development. Today's lesson is on paper 1, exam tips and revision. We are going to start with looking at the knowledge areas in paper 1. We realize that paper 1 is divided into the content of mechanics with a total of 65 marks. We also have wave, sound, and light with a total of 15 marks, plus minus 15 marks. Then we have electricity and magnetism with a total of 55 marks. Then we have matter and materials with the total of plus minus 15 marks. But pay attention to mechanics and electricity and magnetism, which have more marks. The total mark of your paper 1 will be 150 marks, which the duration will be 3 hours, which is 180 minutes. So when you write your paper, just make sure that you are mindful of the time. Let's look at the structure of the paper. The paper is divided into 2 sections. It's divided into section A and section B. Section A is multiple choice questions, which are 10 in total, and each multiple choice question is awarded 2 marks, and that will add up to 20 marks. Section B contains structured questions or long questions with a total of 130 marks. The total of a paper, we have indicated that is 150 marks, written in 3 hours, which is equivalent to 118 minutes. So that is a lot of content that needs to be covered, and hence we are starting with the revision. Now, one of the important pages or sheets that you have on the question paper or previous question papers is the data sheet. So the data sheet is very, very important. Just go through your data sheet and make sure that you understand all the formulas. For example, there are formulas under motion, and then you should know that these formulas under motion are used in question 3 in vertical projectile motion. We also have a table of forces, and that table of forces will be used when you're answering question 2, that is Newton's laws, and also used for question 4, that is momentum and impulse. So that is very important that you look at your data sheet, you understand all the formulas in the data sheet, you understand all the symbols on the formulas, and you know the meaning of all the constants and where do you find the constants should you need to use them. So the data sheet is very, very, very important for your preparation. Continuing with the data sheet, there is another block where we look at the work, energy, and power. Those formulas are given there. So you should know that that is question 5. Then we have wave, sound, and light. So you use these formulas to answer question 6, that is your Doppler effect, and question 10. Question 10, that is your photoelectric effect. So know your data sheet, know all the formulas, know all the symbols, know all the constants before you sit for your examination. Now, let's look at the topics per question. This is how your paper is going to be. Question 1, you're going to get multiple choice questions. Remember, there are 10 of them with a total of 20 marks. And then you get your Newton's laws plus minus 20 marks. Vertical projectile motion plus minus 15 marks. Momentum and impulse plus minus 15 marks. Work energy and power plus minus 15 marks. Doppler effect plus minus 15 marks, and then the list goes on. Electric circuit, electrodynamics, and the photoelectric effect. So these are the topics that you will find on your examination. Just know each question, what is being assessed in that particular question. But very important is that you can start with any question that you understand the most. For example, you can start with question 10, followed by question 6, followed by question 3. So the questions as they answer, they need not be in this order. You can start with the questions which you understand the most and end with the questions which give you more trouble or which require you to think more, or you take more time to think about those questions. So just be reminded that you can start with any question that you like the most. Now, let's look at question 1, multiple choice. There are 10 multiple choice questions, as we indicated earlier, starting from 1.1 to 1.10. Each question has 4 options. The options are A, B, C, or D. Now, before you answer these questions, you must read fully. You read fully and carefully. You read the question fully and carefully before you choose your best option. From the 4 options, there are 2 options which are distractors, and there are 2 options which are very close to the correct answer. Just make sure you start by eliminating the distractors so that you are left with the 2 options which are close to the answer. Then eventually you choose your best answer. Now, when answering these multiple choice questions, you need to identify the topic which is assessed in that question. The topic which is assessed in that question is very, very, very important. Now, after assessing the topic, then you eliminate options that are clearly incorrect, which we call the distractors. Usually there are 2 of them. And then after that, you read again the question before choosing the correct option from the remaining 2. Then you write the chosen option letter next to the question number in your answer booklet. If you are not sure about the answer, do not leave a blank space. Rather, guess the answer or put a sign next to it in case you get time to return to that question. We remind you, answer all the multiple choice questions. Now, some or most of your multiple choice questions might require you to use the data sheet for you to be able to answer. We are going to take you through all those steps of using the data sheet. As we have indicated earlier, that the data sheet is a very important tool to help you pass the physical science paper. Now, let's look at the multiple choice question as an example. 1.1 says a constant net force. When you read the word constant net force, you should be thinking about a number of formulas that are there on the data sheet, such as F net is equals to MA, such as F net is equals to delta P over delta T, and many other formulas that you can look at on the data sheet which are talking about a constant net force. Now, we continue reading. A constant net force acts on an object moving in a straight line. The constant net force acts on an object moving in a straight line. Which one of the following quantities associated with the object will remain constant? The net force is constant, and we want the physical quantity that should remain constant during the motion. The net force is constant, and we want that physical quantity that should remain constant during the motion. Now, we have velocity here as an option. We have momentum, we have acceleration, and we have kinetic energy. Now, for velocity, there are formulas which talk about velocity under vertical projectile motion. look at those formulas. There's formula for momentum, that is P is equals to mv. And there's a formula for that has acceleration and force. We've talked about it just now. F net is equals to ma. And then we have a formula for kinetic energy that is half mv squared. So your K is equals to half mv squared. Now, does this kinetic energy talk about any force? No, this is not talking about any force. The velocity one is also not talking about any force. And then the momentum one, does it talk about a force? You can look at this one, which talks about the change in momentum and divided by the change in time. Does it talk about a constant force and then having a quantity that will remain constant during the motion? No. Therefore, we know that the correct answer here is supposed to be C. How can we validate our answer? We know that this formula stems from Newton's second law of motion, which says that when a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. Meaning that if the net force is constant, the acceleration is also going to be constant because they are directly proportional. So that's why we can validate that option C is the correct answer. The second question, the weight of an object. So now when you read the word weight, you should be looking at your data sheet and then you see a number of formulas. W is equals to mg. And then you will also see the other formula that says F is equals to G, M1, M2 over R squared. Just know that this F here is Fg. In other words, this Fg is the same as weight. So those are the formulas that you can be thinking of as you are trying to answer this question. Now, we continue reading. The weight of an object on the surface of the earth is W, meaning that whatever that we start with on earth, we are going to name it W. What will be the weight of an object on the surface of another planet of the same mass of that of the earth, but twice the radius of the earth? So you see, this first formula here does not have the radius, so we cannot use that formula to answer this question. Therefore, we can use the first formula here, which also has a radius. So we can rewrite the formula as weight is equals to G M1 M2 over R squared. So while we are here on Earth, this bracket is W. Now we go to another planet as the same. But this planet has the same mass of the Earth, but twice the radius of the Earth. So they are asking what will be the weight of the object. Remember, that object should have the same mass as well. Now, that object in the other planet, the mass of the object is the same, the mass of the Earth is the same, but we are told that the radius is twice that of the Earth. So if we substitute there, remember this is the new weight, so weight 2. So this will be G M1 M2. So if we work out the brackets, we are going to have 4R squared. So this 4R squared can be factorized to 1 over 4 into G M1 M2 over R squared. Now we know this bracket. We have seen this bracket from here, that bracket is equals to W. Therefore, we can tell that the new weight is now going to be 1 over 4 W. Remember, the bracket is W. Then we will be able to choose the answer. What is the answer? What are the options? The option A says 1 over 4 W. That's what we got. And that is our answer. And that is how we can use the data sheet to work out the answers on the multiple choice questions. 1.6. An astronomer observes that light spectrum of a star has been blue shifted. Now, before you answer this question, you must look at blue shift. What do we know about blue shift? We know that for blue shift, the absorption lines of the spectrum are shifted towards the blue end of the spectrum. And if they are shifted towards the blue end of the spectrum, this indicates a higher frequency and shorter wavelength. This also indicates that for blue shift with the high frequency, that should indicate that the two objects are moving towards each other. Now, if they are moving towards each other, we should know something about the distance between them. The distance between them is supposed to decrease. The distance between the two objects is supposed to decrease, and we know that the frequency is supposed to increase. Remember, the blue end has higher frequency and shorter wavelength. We know that the wavelength is supposed to decrease. The wavelength is supposed to decrease. Now, let's see as we carry on. We're just looking at what the statement is saying. The light spectrum of a star has been blue shifted. We understand that blue shift means that the absorption lines of the spectrum are shifted towards the blue end of the spectrum with what? With a higher frequency, shorter wavelength, and then that should indicate that the two objects are moving towards each other. And if the two objects are moving towards each other, we expect the distance between them to decrease. Now, let's look at the question. How have the observed frequency of light from the star and the distance between the star and the Earth changed? Now we look at the options. The first option says the frequency increased. Yes, we agree with that. And then it also says the distance increased. We disagree with that. Second option says the frequency increased. Yes, we agree with that. And then the distance decreased. We agree with that. The other option, C, frequency decreased. Disagree with that. Distance between increased. We disagree with that. And then the D option says decrease, frequency, and decreased. Now this one we agree with. So the best answer here will be C. So that is how we work out the multiple choice questions. You need to know the concept that is being tested. You also need to know the topic from which the concept is coming from. Question 2. Now, question 2 is on Newton's laws of motion. And these are the concepts that you need to know before you go into the examination. You need to be able to define define normal force. You need to be able to define frictional force. You need to be able to define static friction, to define kinetic friction. You need to be able to state Newton's first law, Newton's second law, Newton's second law in terms of momentum, and Newton's third law. And then you need also to be able to state Newton's law of universal gravitation. Now, what are the associated formulas for all these concepts? That is the definitions part. Remember, all the definitions are obtained from the Examination Guideline 2021. We do not read definitions from a textbook or from any other source other than the Examination Guideline 2021. Now, after defining the normal force, you should be able to calculate the normal force. How do we calculate the normal force? On the data sheet, you have the formula W is equals to mg, and that W is equals to mg should be used to calculate the normal force. Now, that is N is equals to mg. N is equals to mg is coming from the formula W is equals to mg. When do we use N is equals to mg? Only when we have an object that is lying on a horizon. Let's say this is a 30 kg block. So if the object is lying on a horizontal surface, then we can use W is equals to mg, which can be written as N is equals to mg for calculating the normal force. But now, we also have another formula here. Normal force is equals to mg minus Fy. So when do we use it? We can have an object on a horizontal surface, that is our 3 kg, but this object, we find that it's being pulled by a force at an angle. So this force that is pulling this object at an angle has two components. That is the vertical component and the horizontal component. So we will see that this force will pull this object vertically with a component that is equals to Fy. Then here, when we calculate the normal force, we're going to say normal force is equals to mg minus Fy, where our Fy is equals to F sine theta. So the theta that we are referring to is that one. Then we can also have the normal force being calculated as N is equals to mg plus Fy. So this will happen if we have our object that is our 3 kg, but the force that is pushing this object at an angle is not pushing it upwards, but is now pushing it downwards. So that's when we're going to have a normal force is equals to mg plus Fy. Remember, the Fy is the F sine theta. Then we'll also have a scenario where normal force is calculated as mg cos theta. When is it calculated as mg cos theta? That will occur if our object is now placed on an inclined surface. And then if we are looking for the normal force here, we are going to say normal force is equals to mg cos theta. Now, we also have mg cos theta minus Fy. That will be when the object on an incline is being pulled by a force at an angle upwards. Then we also have mg cos theta plus Fy. So that will be when there's a force pushing this object on an incline at an angle that is towards the incline. So those are the scenarios where we are going to look at the normal force with the formulas that are given there. Frictional force should be calculated easy if we know how to calculate the normal force. Knowing the normal force will help us calculate the frictional force correctly. So the coefficient of kinetic of friction and the normal force. Static frictional force is given there. Given that you know how to calculate normal force, the formula for kinetic friction is also given there. Then we also need to know how to state Newton's first law of motion. Just be reminded that for Newton's first law of motion, the F net is equals to 0. And how will you know that the F net is equals to 0? You will hear words such as constant velocity. Constant velocity. When you hear such words as a constant velocity, you will know that F net is equals to 0 because the acceleration is equals to 0. Newton's second law of motion is very important to know that the F net is the sum of all forces acting on that particular object. And for you to get the F net correct, it means that you must be able to draw a correct free body diagram. Then Newton's second law in terms of momentum, you also need to know how to apply this formula. And Newton's third law of motion, and also Newton's law of universal gravitation. Know all these formulas and know all the definitions for Newton's second law of motion. Now, what are the definite marks that you definitely need to get? Should you know all those definitions that we listed earlier, then we are sure you will get 2 marks for one of those forces. defining one of those forces, you'll get 2 marks. And then you know all your formulas from the data sheet. You will get 1 mark as a definite mark. Formula for calculating force. There must be any force that you will be asked to calculate. And then with Newton's laws, there will always be a minimum of 3 marks for drawing the free body diagram. So just make sure that you know how to draw your free body diagram. So that is a definite 3 marks. There will always be gravitational force. There will always be normal force for objects resting on a surface. So the minimum of 3 marks you should get. Stating one of the laws, you will get 2 marks. Just pay attention. You are defining a force and you are stating a law. That is a definite 2 marks. Using the formula F net is equals to MA is a definite mark. Using the formula for universal gravitation, F is equals to G M1 M2 over R squared. These are definite marks. If we count them, that is 6, 8, 10 marks. So your 10 marks are definite marks should you prepare for your paper 1 as indicated. Now, what are the multiple choice questions that we can expect in Newton's laws? Let's look at 1.2. The force diagram below shows the forces acting on a box. Now, we have a box here with forces, gravitational force, normal force, and the force acting at an angle. And you will recall we have talked about the normal force, how to calculate a normal force when there's a force acting on a box at an angle. And then we did indicate that the normal force here will be Fg minus Fy. But we have indicated as well that our Fy is equal to F sine theta, meaning that this normal force can be calculated as Mg minus F sine theta. So you are prepared for your exam and you know this. Then you can therefore go and look at the options. Which one of the following equations for magnitude of the normal force is correct? So there is no need for you to guess. You just go straight to C as the correct answer. Remember, W is equals to mg. Use the data sheet at all times. The data sheet will help you to choose the correct formula, and eventually you'll be able to choose the best option from the 4 options which are given. Question 2, as asked in the examination question paper. An 8 kg block. You must be able to see the 8 kg block as you read. On a raft. Now, you hear the word raft. When you hear the word raft, you should be thinking about frictional force, meaning that the surface has frictional force. So this horizontal surface we are told is a raft. The horizontal surface we are told is rough and is connected to the kg block, 2 kg block. You must be able to see the 2 kg block. By a light, inextensible string passing over a frictionless pulley. This is the pulley that we are talking about. There is no friction on the pulley, as we are told, frictionless pulley, as shown below. The 8 kg block moves at a constant speed. We have talked about constant speed, and what we know about constant speed is that acceleration is equal to 0. And when acceleration is equal to 0, what we know is that we are going to end up with a situation where F net is equal to 0. So these are some of the things that you should be thinking of as you are reading the question. So the 8 kg block moves at a constant velocity. That's what we know about the constant velocity. When pulled by a 29.6 Newton horizontal force, we must be able to see that 29.6 Newton horizontal force. To the right, we are told the frictional force acting on the 8 kg block is 10 newtons. We are very fortunate. The frictional force is given. Our Fk, we are told, is 10 newtons. Now, let's look at our definite marks. 2.1, state the Newton's second law of motion inwards. we said that this is a definite mark because we have indicated earlier that those are the definitions that you need to know before you go into your examination. The Newton's second law of motion states that when a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. Another definite mark. Draw a free level free body diagram of the 8 kg block. A labeled free body diagram for the 8 kg block. We look at the 8 kg block. The 8 kg block is resting on the surface of a horizontal table. Then one obvious force, which you are going to draw nicely, will be the weight. And then we are going to have another force by the surface, which is the normal force. And then we see the other force there, which is force F. They told us it's force F. You can also call it F applied, but we are told it's F there. Then we see a force by the string. The string is pulling to the left. And then the force by the string is called tension. We remember the word rough. We can make our dot bigger so that it can accommodate us to draw another force. The statement said rough. And because of that statement saying rough, and we know this is moving to the right, we know that the friction, the kinetic friction, is supposed to be going to the left. How many forces do we have? 1, 2, 3, 4, 5. How many marks is it awarded? 5 marks. So 5 marks, 5 forces. Always 5 marks, 5 forces. Then 2.3 says calculate the tension on the string. If we want to calculate the tension on the string, we also remember that this system is moving at a constant speed. Our acceleration is 0, and the net force is equal to 0. They did not ask us to draw the free body diagram for the 2 kg, but the 2 kg can give us the tension force quickly. We can get the tension force very quickly from the 2 kg block. The free body diagram of the 2 kg block will have the weight and the tension. We'll have the weight and the tension. But we know that the system is moving at a constant speed. Therefore, we can write the formula F net is equals to MA. Then we can work out the forces there. T minus W is equals to 0. How do we know 0? Because acceleration is equal to 0. And then we can say the tension minus the body here has a mass of 2 multiplied by 9,8 is equals to 0. Then we will see that we can get the tension here, the tension being 19,6 newtons. So we are able to calculate the tension of 19,6 newtons very easily. Then the next question says the 29,6 newton, they're referring to this 29,6 newton horizontal force, is now increased to 50. So we are increasing this force. Remember, initially they were moving at a constant velocity. Now this force is increased to 50. It's now increased to 50 newtons. Apply Newton's second law to each block and calculate the magnitude of the acceleration. You will get 1 mark here for saying F net is equals to MA. And then eventually now we want the tension. We did calculate the tension earlier of 19,6. But it was moving at a constant velocity. Now that it's accelerating, the tension is going to increase.